So these are the three models that we're going to be going over, or the three lines that we're going to be going over today. So these are known for their precision, the speed at which they print at, and how simple they are to use. Starting from the left, we have our ProJet 2500 series. In the middle, we have our ProJet 3600 series. And on the far right, we have our ProJet 5500X. So we're going to start off with, what's happening with multi-jet printers, right? Why would you have to use these kind of printers? So we use it internally to help expedite our design process. The biggest things that we found is, it accelerates our time to market. We can iterate very fast, innovate better. Therefore, if we have a meeting with one of our customers, they have some suggestions, I sit down with our engineers here. We can toss around a couple of ideas. Even if we don't agree on the ideas, we can go our separate ways, 3D print them, and then come to the table with actual physical prototypes the next day to see which idea actually works better and then move on from there, right? The beauty of this is once you design it, the actual fabrication of the part is automated. So you don't have to worry about a machinist. You don't have to worry about dedicated staff. You just simply do the design work you're already doing, but you get the goal at the end where you actually have a physical part that you can hand over to your fellow engineer to debate the pros and cons of each one of your designs and then move forward. So there's no real hands-on time and labor time that you have to really put into this. It's relatively insignificant. So what can you use MJP for, right? So multi-jet printing is very versatile technology. It's one of my favorites. We work with SLS, SLA, direct metal printing. We have even really simple entry-level consumer printers like our Cube, which is an FDM printer, and Don't Tell 3D Systems. But we also have a MakerBot in-house, etc. They have their inherent limitations. With multi-jet printing, we found that it's one of the most versatile technologies that are available, and it's a relatively reasonable price considering the capabilities that it has. So one of the things is functional prototypes, right? This is what we do day in and day out here at our office, and this is where we really use it on a regular basis. So we assemble test fixtures, we assemble or we design and assemble the parts as designed. We do mechanical functional testing. We also have a lot of situations where we have to use our prototypes in actual fluid kind of analysis. So these parts work well with oils and fuels and diesel. They're extremely watertight, so for any type of liquid application it's very good. Aerodynamic testing is another one. They're very smooth parts. The accuracy is really remarkable. We also have biocompatible materials, right? So for surgical guides, things like that, you can produce it directly right off of your printer. Rapid tooling, this is one of the areas that I think is very, very interesting. And we've also used this in-house quite a bit, and I think this is something that is appealing to companies who do the same parts over and over again. In our instance, we do a lot of different parts once or twice, being that we're a design house. Let's say we had said widget and we always want to iterate said widget, and when we do get the widget optimized, we want to actually make more than just one of them, or 3D printing is just not capable of producing the part one-to-one. So what do? There's a lot of different ways. So we can do short-run injection molds, so we can actually print out the mold on our 3D printer and then get dozens, in some cases hundreds of parts out of an injection mold. Then we can do jigs and fixtures. So let's say your part has to be metal. So instead of spending the day or 2 days machining out the jigs to then be able to machine out your part, you can just 3D print them and then get right over to your part. Hydroforming is very interesting because we'll show a video, an example of that, but that's, those are very thin laminate metal parts. That's the end product, right? And obviously 3D printing materials don't quite hold up to those sheet metal type parts unless you're doing direct metal printing. So how do we get around that? We can actually design a tool for you to use for hydroforming, thermal forming as well, vacuum forming, RTV molding, sacrificial casting. So if you want to get to metal, let's say jewelry, dental, things like that, dental labs, instead of doing manual wax ups, what you can do is you can actually 3D print the wax up, then burn it out. So therefore you don't have to pay the labor for somebody to be whittling away at plastic or wax the entire day, and then hopefully they don't accidentally drop it on the floor. Then you have to spend all that time fixing or just creating it from scratch again. So you can actually just 3D print tons of them. Actually, my engagement ring, or my wedding ring, and my wife's ring, we 3D printed and then had cast at a local jeweler as well. So it's kind of fun to have this in house. Conceptual models. So this is more you know, of the common uses, right? Rapid design iterations, communications for sales and marketing. We're actually currently running 2 or 3 projects for our customers right now, which we're using 3D printing solely to help their marketing and sales staff. So we're designing a product which isn't ready yet. Sales wants to start get the ball rolling. Video animation is not good enough for them. They want to have something in their hand. So what do? We 3D print it, and then now all of a sudden they have a sales tool in their hand they can show their customer to help push the sales and get their ROI on their product earlier on. So that's the kind of things that, you know, kind of fall a little bit outside of the box when people think of 3D printing. Architectural engineering and construction models as well. You know, really high detail architectural models can be accomplished with this without the amount of labor that is traditionally needed. An example is we helped do an architectural project where we had to 3D print several different buildings. In terms of hands-on labor, near nothing, right? We just had to post-process the parts. When we asked the customer, why do 3D printing when you have an entire staff to do this stuff, he said, well, because I needed it fast, and it was going to cost me far too much to have my staff make it from scratch as well. So, you know, even people who have staff to make things manually are starting to see the benefits of just hitting print on a 3D printer. Now, that said, there's always certain limitations. So I'm going to show a quick video on how MJP printing works. There's no audio to this, that way you guys can hear my joyful voice over it. But anyway, in general, you get your 3D file, you submit it to a modeling client. It'll actually then split it up into layers. Once it slices it up into layers, sends it over to the computer, and then, to the computer inside the printer. And then what it does is actually starts laying down 2D images of each one of those, just like it would a 2D printer. We actually have over 600 jets inside of the print head, and it starts laying down part and support material as it starts printing. As it prints, the print head starts going up. In some of our printers, the build plate actually starts going down. So that's one variable there. So the support material in our situation is wax, and the blue material that's shown there is an acrylate photocurable resin. The good thing about this is that the acrylates come with different types of mechanical properties, also different colors if you need something that's clear. We have things that are ABS-like, polypropylene-like, etc. Right here you're seeing how it is to refill your machine. So you notice there's actually 4 containers there. This specifically is on the 3600. That's how you actually refill your machine and you get rid of the old material. This is actually a 5500 in action. You notice the white support material, the kind of amber-colored acrylic material. This is actually on a 3600, slightly different setup. In general, though, you notice that we can do wax patterns and have them cast. We have functional, rigid plastic parts, and we can do very small, complex parts as well. Okay, so what makes MJP better, right? So why are we looking at multi-jet printing over other types of technologies, right? So multi-jet printing is something that can produce extremely high fidelity parts. You can also produce very small, fine features, extremely easy to post-process, and you have more geometric freedom. So unlike other technologies where you have breakaway supports, wash-away supports where you need to actually use pressurized water, all you have to do is put this inside of an oven and it actually melts away. So you're able to do very, very complex internal structures. You don't have to worry about overhangs, things like that. You're going to get the same accuracy and surface quality on any type of geometry that you spit to this machine, which is incredible. Next up is us compared to other jetting technology, right? So if you notice the holes inside here, you'll notice on the left is our multi-jet printing technology. On the right is what's called polyjet printing. There's a significant resolution difference between multi-jet printing and polyjet printing. I'll get into details as to why in a bit, but you can notice just off of this image There's extremely sharp corners in our parts. All the edges are visible. You can even make very, very fine geometries. It's easy to post-process. All the support material is gone. So it's very, very good for very high-resolution applications. This is another one that was taken off of a case study from one of the customers. They actually produce irrigation systems, and they needed to come up with a spray pattern. They actually had to go with a multi-jet printer over a polyjet printer because the polyjet printer was giving them false results. So this is actually what we would call a false negative. The person actually designed the part properly. When they 3D printed it and the 3D print came out slightly out of shape from where it needed to be, the jetting pattern of the irrigation system was actually wrong. So it wasn't necessarily because the geometry of the design was wrong, it was because the 3D printer was not capable to produce a geometry that needed. So therefore, this fine detail, though, might sound like we're nitpicking. It could mean the difference between false positive or false negative, which could be very, very detrimental to timelines and costs. So, you know, the devil's in the details, and therefore we try to embrace the fact that we can do very, very, very tight corners. So how does our jetting technology do that, and compared to the other jetting technology, what's the issue? Well, we have what we call phase change material. So we have better droplet control. So this is an oversimplified diagram, but it's essentially when our material jets, it goes from a liquid to a solid as it's jetting. So therefore, we can control the geometry very well. Where with the competing polyjet printers, they do not have a phase change material. So when the drop drops down to the build plate, the drop is actually not precisely controlled, and then therefore not able to produce the sharp edges that we have in order to create that extremely high accurate part. So jetting is very important. We have phase change control, so the parts are actually very, very sharp edges, and our droplets are very well controlled because of the phase change process that multi-jet printing is able to offer over other jetting technologies. Other reasons why multi-jet printing might be the choice for you guys. Post-processing is, I got to say, is one of my favorite parts about multi-jet printing. Like I said, we've worked with a lot of different technologies here. Of all of them, multi-jet printing is the easiest to work with in terms of post-processing. Why do I say that? Well, because in this scenario, hands-free, you don't have to worry about damaging the part. It's actually very fast. You don't require any type of plumbing, no chemicals, and we can do it in bulk as well, right? Let's compare that real quickly to other technologies. Simply, let's just talk about SLA. Even if you're talking about professional level SLA systems or consumer level SLA systems, there's breakaway support, right, to one extent or another. The other thing is you have to put it through a wash, and then you have to UV cure it. If you talk about FDM printing or plastic jet printing, like 3D Systems would call it, there's also breakaway material, in some cases soluble, but the soluble is actually not what you would think, that you just drop it inside of a vat and it's done. It's actually overnight, and you might have to put it in an ultrasonic cleaner, you might actually have to scrub it after the fact, etc. And now when you start talking about our other jetting technologies, those actually require water jets, some plumbing, so you do have to take into consideration certain things, and you also require chemicals for that as well. So in our scenario, you're simply just putting a part inside of temperature-controlled oven. From that point, you just let it drip away, and you have a clean part. I'll show a video of that a little further on. So with polyjet printers, with multi-jet printers, you can actually create ABS-like, polypropylene-like, polycarbonate-like materials. We also have flexible elastomers, black, white, clear, gray, and we also have multi-material composites. So we can do 2 materials at a time, so that you can actually do, let's say, overmolding type applications, things like that. These are, again, the 3 printers in our line. What I'm going to do is get now specifically into our ProJet 2500 series, which is this little guy over here on the left. This is our new product for the year. It's actually selling like hotcakes. It's very, very competitively priced. To create the type of precision that this printer actually creates prior to the beginning of this year, there's really no printer on the market that was sub 100 grand for that kind of quality. So this is really starting starting to bring the price point down on extremely high precision professional level printers that are built to last. So these are considered capital equipment purchases that will last you a while. So don't think of this as a printer that you're just going to buy. It's going to be obsolete in a little bit. These printers, they hold up to a beating. They're workhorses, and you can really run them hard without having to worry about them. So you get what you pay for. These are very well built machines that will last a good amount of time. So the Project 2500, best thing about it is it's almost as precise and accurate as our bigger systems. It has very high speed in terms of printing, and it's extremely easy to use, right? Let me show you a quick video from 3D Systems on this system in particular. That way you can see a little background about it. So that's a quick view of the 3D Sprint software. We'll go over a couple of the benefits of that material, I'm sorry, of that software later. That's the size of the printer. If you notice, it's about the size of a desk. It's quiet, so you don't have to worry about where you put it inside the office. As loud as it'll get is about the sound of a refrigerator. It's very, very clean. We actually have ours here in the office, actually 3 feet away from mine right now. So unless you have very good hearing, I don't think you can actually hear ours in the background. So it's a very, very nice, quiet, clean machine, and it doesn't give off fumes. You don't have to worry about how it smells. Post-processing is very easy and clean as well, and the parts are very high precision, rigid or flexible elastomeric materials available for this. So what are the pros of the 2500? High resolution, high fidelity, and actually affordable. So like I mentioned earlier, printers that that create this kind of resolution and accuracy don't start to sell for very much under 100 grand, where the 2500 actually comes in significantly below that. So now you have access to what used to be a 6-figure acquisition at a significantly lower price, which is nice across the board. Even when you look at our competitors, etc., you cannot get this kind of quality in that price point, period. The setup is very, very easy. I mean, it's comparable to, and even in some cases more simple than consumer level printers, right? You can have this thing run 24/7, and it doesn't have to be taken care of. So, for example, a lot of the times what we do here, we'll have design meetings in the morning. We'll have our engineers implement those design changes during the day. We'll submit a print at night, and the next morning we have a meeting to review our parts. With this printer now, with the amount of speed that it has, if you have your file ready in the morning, in a lot of cases you can actually get it in the afternoon as well. So these printers are actually starting to get to the point where you can literally have a morning meeting, an afternoon, you can actually start to get some parts and look at it as well, depending on the size of the part as well, right? So we'll be honest with each other, if you have a massive, massive part, it's going to take overnight to print. But if you're doing something that's really quick, small, you can actually get it in a very short period of time to review your decisions that same day. Resolution, right? So in this scenario, I always like to compare this back to Apple, right? So Apple introduced the Retina display a few years ago at 400 dpi, which is more than what the human eye can actually notice, right? So we're actually printing with the 2500 at 790 dpi. So it has more resolution than the Retina display from Apple. So if you noticed when you looked at your screen as soon as you saw one of those Retina displays how crisp and clean that was, well, now compare it to something that's almost double what that Retina display was. So we're getting extremely high resolution, high fidelity parts out of these printers. All right, next thing is network ready, right? So if you have a team of engineers that want to work on this, you can actually submit different from your own desktop. It's a really simple client software that you can add to your desktop or your laptop. As long as you're on the same network, you can submit your prints from anywhere. I actually have in the past been in my apartment, finished up a design, and submitted it from my apartment to get printed in the office. So it's actually pretty nice that you can do that remotely. If you're on the same network, you can manage queues. So if you need to prioritize certain prints, etc., So that's one of the biggest benefits that I see. You don't need a dedicated PC either. So as soon as you submit the file, all the printer needs is power, and it'll go to the racehorses. So it's not going to be taking up any of your bandwidth in terms of your computer. It'll be using its own processing power. You don't have to worry about the connection dropping between file transmissions or anything like that. So some printers actually require a dedicated computer, and if that computer goes to sleep midway through a print, you all of a sudden lost your print, etc. With this one, you don't have to worry about that extra added variable the issue that you might have to worry about. Also, for the post-processing, you don't need any type of plumbing, and it's not dirty. Right? So you can actually literally put this in an office scenario, and you can post-process your parts. You don't have to worry about smell or fumes or anything like that. So the other thing is the 3D Sprint software. So this is actually one of the nicer things about working with a 3D Systems printer. It does printability checks, right? So it'll warn you if there's some areas that just are not printable, right? So as much as we'd like to say these printers can produce any type of geometry, there are some limitations in terms of wall thicknesses, right? When you start to get into fractions of a millimeter of thickness, it might start to be a little bit of an issue. So it'll actually check for printability issues. Also, it'll check the STL file to see if there's any errors when you exported it. It'll give you, so you do file repair. It'll give you build time estimates and material estimates, so you know how much it's going to actually cost you if you want to calculate the cost of a prototype, or if you're doing it as a service for a customer, you want to make sure you associate that cost to a certain project. Automatic part positioning, so there's no learning curve, or it doesn't take any rocket science to figure out how to put these parts in there. You literally just drag and drop files into this and then hit the auto orient part, and it's going to generate the position optimized for printing, and then it's also going to automatically do the supports for you. So there's no learning curve like you would on like an FDM or an SLA machine where, oh, well, you know, I don't want supports on this face, so I need to make sure I orient it in a certain location or manner so that I get the best fidelity on my part. So I need to do X, Y, and Z. So with multi-jet printing, orientation doesn't matter with part quality. You can orient the part however you see fit, whether you want to have it print out faster, or maybe you want to put it straight up and down because you need to fit some more parts on the build plate, you need to nest something. Feel free. Your part quality is going to be the same regardless of the orientation. So you don't have a learning curve as to, oh man, I don't know how to orient this part because this face is my important face, this is where I have critical dimensions, I can't have support there. So you don't have to go through any of those. You simply just drag, drop, hit print, you're good to go. So you have the geometry to print out, and it's in bold. Any geometry, yes, but you know, let's keep in mind there are some limitations, especially when you're talking about architectural type applications. You have to worry about when you scale an entire building down to, you know, 1/100th of a scale or 1/1000th, whatever it might be. You know, an 8-inch wall all of a sudden turns into paper thin. So in those scenarios, you have to be a little bit careful. But in general terms, anything that you intended on producing with mass production or any other form of fabrication, a 3D printer can handle very, very easily. So what materials do you have available on these printers? So with the Multi Jet, the ProJet MJP 2500, you have a rigid white and a rigid black material, which would be the two top ones seen here. And then with the Plus, you actually open up the options to a clear and then two elastomeric materials. So you can actually have a clear part and then two elastomeric materials as well. So again, regular 2500, and then the Plus adds a couple more material options. So if you need just really high precision plastic parts, you can just stick with the 2500. If you need clear or elastomeric, you'd have to start looking at the Plus model. Next thing, how do you clean these? So this comes with what we call an easy clean system. It does things extremely quickly. You can post-process things in under 30 minutes, and when I say under 30 minutes, it's not 30 minutes of your time, it's 30 minutes post-processing. You're actually literally just dumping the part inside of here, coming back 30 minutes later. So don't think of it as 30 minutes of labor, right? So that's one of the biggest things between our systems and competing systems, or even other technologies outside of MJP, it does take time and labor to post-process parts. In this scenario, which I've worked with a lot of different technologies, it is the one post-processing, not to be redundant, process that actually doesn't require a lot of hands-on time or learning curve. So for example, with my FDM prints, we have to worry about when we break off the support if we accidentally break the part, or if we leave a dimple that's too big, we have to sand it down, etc. SLA, we need to make sure we clean the parts properly and then put it into a UV finishing oven, and then after that break off the materials. With our color jet printing, there's powder involved, SLS as well. You need to bead blast the parts, clean off the parts, etc. With multi-jet printing, it's literally easier to maintain and work with than my HP printer that I have connected, where sometimes paper gets jammed, etc. I have to ask one of the guys in the office to help me out with it. With one of these printers, it's just as easy. We've had our secretary submit files for us because we haven't had an engineer in the office. Literally little to no learning curve on these systems, and also with the post-processing. So that's one of the beauties of it, is human error starts to go out of the window when the system's that automated. So why would you get a 2500? Productivity, resolution, accuracy, and simplicity. Simplicity. So this is not going to give you the biggest build volume, but it is very fast at printing. It has very high resolution. It's extremely precise and very, very easy to use. And when I say this, basically these 4 bullet points are going to be applicable to the other 2 models that we're talking about as well. It's just MJP in general is extremely accurate, and it compares to, you know, the type of precision you're going to be getting off of printers that are several hundred thousands, in some cases millions of dollars. You get that kind of resolution on a very, very inexpensive office-friendly version. So a little bit about the specs on the 2500. You can see the build volume on the top there. So we have 11.6 by 8.3 by 5.6 inches. In all honesty, we do product design and development day in and day out. That fits 90+% of our products, right? So a lot of the times people say, oh, well, you know, it's a pretty small build volume in some cases, or some say that's too big, etc. Long story short is each individual part that we design here, 90+% of them fit in there. And if we're not printing out a large part, we can just fill it up with a potpourri of smaller parts, and it's not going to really add any build time. So that's another thing with multi-jet printing that I wanted to point out. We have a massive print head that goes to and from over the top of the entire build plate. It's a very robust print head, so it's not considered a consumable. It actually has a standard 1-year warranty and an optional 5-year print head warranty on the 2500. On the other models, standard 5-year print head warranty. So don't think about print heads as something you have to replace and maintain, etc. These machines are self-maintaining. It goes through a cleaning cycle every time you start a print, so you don't have to worry about that at all. And the print head is large. In this case, the print head is slightly more narrow than the build plate, so it does have to do 2 passes. On our other systems, it's just as big as the build plate, so therefore if you're printing out 1 part, it takes you 1 hour. If you're printing out 100 parts, it takes you 1 hour and 10 minutes. So it's not a huge incremental add-on in terms of time when you actually start adding more and more parts. So I actually encourage, you know, waiting to the end of the day, submit all your parts at the same time. That way you just take advantage of the build time all at once. It's not like FDM or other technologies where if it's 1 part, it's 1 hour, 2 parts, it's 2 hours, etc. With here, you get a small incremental increase, if anything, when you start adding parts. So now moving on to our 3600. Sorry, I've kind of glazed over that slide too quickly, but the 3600. Why would you want to go with a 3600 over a 2500, right? So this is more investment. The build volume is a little bit bigger, but why would you spend the extra money on a 3600? Well, because you want to have more material options and a little bit higher resolution. Also, maybe a slightly bigger build volume. So I'm not going to say that the part quality is night and day between these two, because the 2500 has very, very good part quality. When you get to the 3600, you have slightly better part quality. This is when you really, really need high precision parts and you want the best that's on the market. Then you start looking at the 3600 because we can get the sharpest corners and the smallest holes and the tightest tolerances that you can, period, on these machines. So here's a real quick video on the 3600 so you guys can see the general size, shape of it, the software that goes along with it. Now you can see kind of the build volume that you're going to be looking at. It has a nice massive touchscreen on the front that makes it very, very easy to use. In this scenario, you notice the print head is that big black thing in the back. That's the post-processing on it. So the printer produces extremely fine detail parts. You notice here we had very thin impeller part in there that one of our local customers did, in that black part there. They actually then use that part to then cast it, right? So I'll get into what the materials for the 3600 are and why you might want to look at this over 2500. That's an injection molding application. So why the 3600 then? So again, bullets are basically the same, high fidelity, high precision. This has now the finest details and a superior surface finish over the 2500, and also other jetting technologies that are out there. Job submission and post-processing is very, very simple. So you notice the image on the top right, or the GIF, is how the parts are post-processed. You just simply put it inside of a temperature-controlled oven that has a drip pan underneath it. It's sold by 3D Systems as well. We also have other options that can give you the ability to put it inside of a steam bath, which is an easy clean option that I just showed it to you, which actually melts out the part a little bit faster. But essentially that's what it is. You just put it inside of an oven, let it melt off, and you see the wax just basically drip out. What we do after the fact is we'll just get a lint-free cloth to dab it off, and then your part's good to go. The bottom right is actually the build volume. So you notice how you can nest all the parts in there, and it's only going to take as long as your tallest part. So if you have one part or 10, the same size, relatively same build time. Now as soon as you start increasing that vertical height, that's where you can actually start adding some build time to your print. So try to orient your parts so that they're lowest to the build platform, because these things, again, this is additive manufacturing. The more layers it has to put down, the longer it's going to take. That's just the way it goes currently. Next thing is, now we're talking about high throughput, right? So we have really fast printing times on this with extremely high resolution. So this is at our UHD mode, right? So this is when we're talking about 27 micron layers. So these are very, very thin layers, and we can actually build this entire build plate in 7 hours. And if you go to UHD, you can do it in 11. And if you compare that to other jetting technologies, you're talking about almost or more than double in one scenario and almost double in the other scenario. So you have very fast throughput. I always like to keep my builds under 12 hours. The reason being is because you submit it at night. When you come back the next morning, you want your parts to be ready and good to go. When you start getting over the 12 to 16 hour range, now all of a sudden it starts eating into 2 business days, and that's not what you want a 3D printer for. You want, worst case, you want your parts the next day. In some cases, you want to get them the same day, right? All right, so now with the 3600, it opens up your applications to a little bit more than what you had on the 2500. So basically looking at the bottom 3 blocks here. You want to notice that now we have high temp material, right? So now you can start using injection molding type applications where you can print out the mold and inject it with the specific plastic or elastomeric material that you want. So a lot of the objections I get on a day-to-day basis trying to sell 3D printers is, well, my end part isn't plastic, or I need exactly ABS, not ABS-like, or I need exactly polypropylene, or I need this exact TPE, or whatever it might be. Okay, not a problem. Now that we have high temp materials, 3D print the mold like you would out of, have to machine it out of metal, and then inject it with the material for a test. You like it? Okay, good. That mold's going to hold up for quite a few cycles after the fact while you're machining your steel mold for mass production. So this can actually even be used for bridge manufacturing, right? So optimize, optimize, optimize. You get to the mold that you like. All right, well, let's use it off of the 3D printed part while we machine the real deal that's going to be working for us in the long run. The next detail here is castable, right? So we can actually print parts depending on the printer that you're looking at, whether it be our 3600 that has a castable acrylate material, or if casting is the only thing that you do, we also have a real wax 3600 that will print directly in wax for you to be able to cast your parts the same way you do regular wax parts without any type of learning curve. With the acrylate, there's a slight little learning curve there. So we do have how-to and best, how-to guides and different types of documentation to help you cast acrylic material. But if you want to just continue casting the way you cast already, wax, we do have wax printers as well. You also have this biocompatible material. So this biocompatible material is not good for implantation, but it's good for contact with the body. So you can actually do surgical guides and things like that. So now all of a sudden, you're getting more function out of your 3D printer as opposed to just shapes, right? So versatile applications, like I was saying. So you have, same things that we were doing with the other one, which is design verification and testing. Assemblies including snap fits. You have watertight, which is also same thing that you got with your 2500. Then we have our Class 6 biocompatible applications. We also can do rapid tooling. So the rapid tooling is actually very important. This is what starts making things functional for people. This is where the objections to, well, I don't use plastic parts start to go out of the window. You do silicone parts, RTV molding, extremely fine details, jigs and fixtures, etc. So your applications start opening up to a much broader range. The other thing is low cost of ownership, right? So with the 3600, this comes standard with a 5-year printhead warranty. You do not have to worry about if it's going to go down or break anytime during those 5 years. Labor is included, the parts included. It's going to be fully supported, so you don't have to worry about buying printheads every year like you would with the competing technology. Minimum maintenance, I'm telling you minimum maintenance because it is minimum maintenance. We have consumer level printers and other printers that do require a little bit more maintenance. These are basically maintenance free. It maintains itself. So you hit print, goes through a cleaning cycle, starts printing your part. Then all you have to do is clean the build plate, which all you have to do is get a razor blade, scrape it off, reuse the build plate. You're done. You're good to go. So maintenance, ease of use is huge on this printer. Again, so now we have a little bit more, one more bullet point here. We have versatility, right? So you can do injection molding, casting, things like that. So you add a little bit of versatility to your design once you get over to the 3600. A little bit of stats on the 3600, and notice the build plate's slightly bigger on the 3600. We have 11.75 by 7.2 by 8. And then when you have the HD Max version, you have that build volume through all resolutions. When you have the standard 3600, you do have a slight build volume decrease when you go up in resolution. Materials are available for both units, so you don't have a difference in material options like you do with the 2500. All the materials are available on both 3600s. Here are the layer thicknesses, which, and I'm sorry, I think I said 27 microns before. It's 29 microns for UHD. HD is 32 and XHD is 16 microns. So if you have really, really extremely fine detail that you need to hold up, you can go to that 16 micron layer. Typically in-house, we don't go below 29 microns just because we do injection molded plastic, and that is, even in a lot of cases, more precise than our injection molded part is going to be. So we stick to the UHD mode, in a lot of cases, the HD mode, because it's more than precise enough. Typical accuracy plus or minus 1/1000th per inch, 1 to 2/1000th per inch of build. Post-processing is a temperature-controlled oven, like you saw in that real quick video, and then standard warranties, right? So 1 year parts and labor. So the first year, literally just purchase the machine, everything's going to be taken care of. Every year after that, we do have a service contract, a reseller that we offer, and then beyond that, the printhead is included for 5 years off the bat. So the printhead is what you have to worry about on a lot of these printers. That's what tends to go bad. 3D Systems backs up theirs. This is industrial style equipment. It works. It's a workhorse, so they're able to back it with that warranty. Now, the 5500. So this is the next step up in the food chain. We went from the 2500, which is very affordable, gives you extremely high resolution. Then we went to the 3600, which has a high temp material, starts broadening your horizons in terms of what you can start using the parts for. And then now the 5500X, which is our, I guess we would call it the flagship MJP printer, right? So now you can actually start doing multiple materials at once, and this is multiple materials at once for a very, very competitive price with a huge build volume on top of that. So let me go ahead and hit print on this one. That way you guys can see the general size and process that goes on with the 5500X. So you'll notice in this printer you can actually do multiple materials in the same print. You have flexible materials, rigid materials. You can even do complex assemblies like that camera there. Even tires that you want to put some labeling on the outside, whatever it might be. I think overmolding is one of the best applications for this printer. Whether you're Gillette or some other manufacturer that has grips over your plastic parts, this is a great 3D printer to test those things out with. Gaskets, seals, things like that, those things are great as well. So you can really start working with your printer quite a bit. So let me take a quick break. I need to ask a couple questions here because I know we need to learn a little bit from you guys. So we want to ask, what do you guys currently use 3D printing? And if so, do you use in-house, do you outsource, or you do not use 3D printing, period? Okay, we just have a couple more people that need to answer. Okay, and thank you. I have a quick follow-up question. Are you currently looking into buying a 3D printer? So we love doing these webinars. We like educating our potential clients. We're also interested to see if maybe we can help you guys out. So we offer 3D printing as a service, as well as the ability to purchase a 3D printer. So if you're not ready to actually purchase a 3D printer, that's fine. That's not a big issue. We can actually help hold you over in the meantime while you get budgets corrected, etc. Okay, thank you. Also, we're curious what you want to use your 3D printer for. So these 3D printers, they have a versatile set of uses. We want to make sure that we know what you want to use your 3D printing for. Why? Because we like to help narrow down your options to the 3D printer that best works for you. It may not be a multi-jet printer, it's the best printer for you. You might have to look at our SLS or SLA system. So we might have to look at maybe even one of our color jet printing systems. So we always like to know, why are you guys looking into 3D printing? What are you going to be using it for? So I'll give you guys a couple more seconds. We have a couple more people that need to vote. Okay, and we're done there. Okay, so let me go ahead and move on. I want to keep going here. You know, we're starting to run low on time, so I want to make sure we get through all these slides, which we're almost there. So with our 5500, now we can start producing objects like this, right? So like this Formula One car, you know, soft tires, rigid frame, ABS-like. You have more flexible aerodynamic aspects of it, etc. So you can actually start playing around with how hard and how soft each one of the parts are. And you have a wide array of different applications you can now start using this for with a big build volume. So the build volume on this printer, with the precision that it has, is unrivaled. It has extremely high precision and a big build volume, and it's in a price point that's completely separate from what you would see in terms of, let's say, an SLA system that has a comparable build volume. You'll notice here that we have clear applications, soft, rubber, you know, rigid, So you can actually start to broaden your horizon in terms of what you can expect. These are the materials in general, right? So we have our rigid clear on the left, which is actually printed with an overmolded kind of rubber grip. We have the one that's in the second from the left, which is our rigid white material, which was actually, again, 3D printed, overmolded with the rubber-like grip on the bottom. This is actually off of a case study called Derby the dog, so if you want to look up Derby the dog, it's really cool. It's a dog that was born without his, or with a mutation in his two front legs, and now the dog has these prosthetics which are 3D printed, which is a pretty nice story. We have extremely elastic material, so compared to our the other technologies, our elongation is incredible, and it actually recoils pretty nice, so it's really, really nice material. This is a real quick video to kind of prove how elastic this material is and how resilient it is. So I'm just going to run it. This is, I believe, a 20-pound weight that they put on the bottom of this. This is printed on the 5500X. That's actually just a print of Derby, the dog. And we're going to show briefly after this the video of stretching and then how it actually comes back. So the elastomeric material is not what you probably have seen before, where it's actually kind of brittle. In this scenario, it's actually not, and it recoils back really, really well. So it stretches very well, comes back very well. So it's not going to plastically deform on you after you stretch it once. It's not going to be a flattened out, piece of rubber. It'll actually come back as a very good memory. Okay, so material properties. So how do you do this? You can actually create a almost limitless amount of durometers here. So it's a very analog kind of setup. You have flexible, rigid, and you have black, white, and clear. So our black material is a flexible material. Our clear material is rigid. White is kind of polypropylene-like. So you can actually create a wide variety of different material properties, which is nice because let's say you want a higher durometer grip on something and a softer durometer area on another. You can do that all in the same print without having to do any type of material changeovers or anything like that. So you can really dial in the shore A hardness that you're looking for. This is a good example where you can put multiple materials, multiple different things on the same build plate. So now the build plate is actually extremely large. I believe we're about 100, I'm sorry, almost I think 50% bigger than the competing technology. So we have an extremely large build plate in comparison to the competitors that are out there. Also, the build speed is very fast in comparison as well. So you can actually use your printer for large parts and get them quickly as opposed to waiting several days. So you have this is an extremely large part right here. It covers almost 21 inches across one side of the build plate. I believe it's actually somewhere around 6 inches tall. So this part takes 18 hours. So yeah, it's an overnight build. It's probably going to eat into your next day a tad bit, but when you compare it to other technologies, you'll be talking about 36, 48-hour prints, which starts to get extremely time-consuming when you're trying to get something this size with a high level of resolution. The next thing is, yes, versatility again, right? So medical modeling is actually getting pretty big. This is good because it has different material properties. So they've been 3D printing the anomaly in one material and the regular anatomy in another material so they can practice their surgical applications. You have very small, clear, high-precision plastic parts as well, just like this. I think it's an old-school emoji or something like that, or at least that's what it looks like, but I think it's actually to check your blood sugar, but I just remember that from when I was in school, those little fighting digital dolls that you had. Okay, again, so low cost of operating. So this, when you compare this to other polyjet, multi-jet technologies, the competing technologies cost quite a bit to run. You have a lot more waste when it comes to support material. This prints out very efficiently. You don't have to worry about print heads, so your cost of ownership is actually significantly less. Your cost for material is slightly less as well, so you you run into the situation where you're investing less, you're spending less over the course of a period of time, and you get extremely high resolution parts. So it's really nice to see that, after you purchase the machine, it's not going to run you into the ground. It's actually relatively inexpensive to run. And also that the cost of running this machine starts to diminish to near nothing when you start to consider how much you would have been spending on CNC machining, outsourcing, things like that. So, take into consideration how much you are currently spending on machining, prototyping, how much time your machinist is actually taking, what you can actually be doing with that machine other than this part that you can actually just be 3D printing without having anybody on it. So take into consideration not just how much does my part cost, think about opportunity costs. What could you be using your other equipment for instead of prototyping? Or if you don't have any equipment, how much are you going to be paying somebody down the street to do this for you when you can actually just hit print? Again, the 3D Sprint client software. So this goes over basically the same things. This is synonymous to what the 2500 has, except for now you have the added, material selections or different types of durometers that you want to put into the materials. Accuracy, again, the bullet points are basically the same. In this scenario, you have high throughput, right? So you have a very big build volume. Don't necessarily have to be just for big parts. If you have a run of small parts, for example, we have a medical device that we were developing for a customer. He needed biocompatible parts, and he needed them in a matter of 3 days, needed 200 parts. Luckily, the part was relatively small. We actually were able to fit all 200 parts on our Multi Jet printer and have them to him the next day. So, things like that are just not possible if you're CNC machining or injection molding. You actually there's setup time, there's manual labor involved. We just literally had to get the part, make an array of the amount of units that he wanted, hit print. The next day we had all the parts ready to go for him. So, quick throughput is key with 3D printing. Again, specs on the 5500X. So we have large build volume. So 20.4 by 15 by 11.8. The multiple materials and the same high resolutions that we have on the other one. In this scenario, our HD mode is actually higher than our UHD mode on the 3600, so you have higher resolutions on this one. You even go down to our XHD, which is 13 microns, which is extremely high precision. Again, same accuracy, 1 to 2 thousandths per inch. Post-processing is the same, and here you have the standard warranties again. So some examples of applications. I'll kind of be swift through these, but these are pretty cool and nice to see. So this is one for conceptual modeling. This is from Citizen Watches. They were able to use this type of technology to make their parts. They actually saved 3 times on installation costs, and they did it in 6 months. They protected their IP, right, because it's all in-house, so you can actually compress design cycles and save money at the same time. They don't have to be inversely related. This is, real quick functional prototype, so it's really fast to check early on before you go to injection molding. The good thing is you can prototype with confidence. These parts are going to be one-to-one with your CAD, and in a lot of cases they can even be more precise than your injection molded parts. So that's where I say be careful, because if you don't do your mold flow analysis and you go to injection molding, your injection molded part is going to come out warped, where your 3D printed part is going to look fabulous. So just make sure that now you're running into 3D printers that are extremely precise no matter what you throw at it. And when you go to manufacturing, the manufacturing does have some limitations. So I'm sorry about the audio. This is just a gentleman that uses injection molding. Either they want to create 3D printed molds and then injection mold them. So he's talking about here where a typical injection molding time would take 2 to 3 weeks, $6,000 to $7,000 to deliver a part, where now they're doing it in 12 hours, and they're able to turn around parts in a matter of 72 hours. So they get the file, they 3D print it, they 3D print the mold, and then they start injection molding, and then they ship it. So from the day they receive the file to when the customer actually gets the part in their hand, it's actually 72 hours for injection molded parts, which is pretty insane if you ask me. This is off of one of our real wax printers, so this is a 3600W printer. So they actually print it out in wax, and then they actually cast the part to be put directly onto a Honda motor. So this is something that they will typically would take 4 weeks, and now they can get it done in just a matter of a few days. Next thing is hydroforming. So you can actually use this kind of equipment to make other parts, i.e. metal parts. So if your parts are thin metallic parts, you can actually 3D print a mold and hydroform them over the top of the mold. Same thing with vacuum forming. You print out the mold, then you print it out. This is the next version is now hydroforming here. So you can do same-day tooling on the 30. Well, this is 3500. This video is from our preceding printer, which was almost exactly the same to the 3600, except for the 3600 now prints twice as fast and has a couple improvements in terms of user interface and software. So you notice in here they got the block printed directly off of the printer, then they put it in a hydroform machine, and now they actually have a end-use part. And they actually, I believe in this scenario, they used it over 100 times. They didn't see any wear on the actual part itself. So as you notice now, 3D printing is not just plastic parts. It's actually real end-use parts. This is an example off of a 5500. With the 5500, you can actually make end-use kind of prototype parts where you can use multiple materials, do some field testing, etc. So you can actually see your part and see how it works out on the field prior to getting any type of injection molds made. Really complex, small robotic parts. This is something that was done in Italy, where they made a grasshopper out of 3D printed parts, which is kind of cool. So you can do very small, complex parts very, very easily. Intricate valves, right? So this company had to do valves that were watertight, only technology that you can use for that kind of stuff. Other materials absorb or just don't hold materials that well. Okay. The next thing is, so with all of these printers, you can do RTV molding, hydroforming, thermoforming, vacuum forming, fiber layups, sand casting. So there's a ton of different applications. We're actually working with a customer right now that is looking to purchase one of these printers for the sand casting applications. They actually do iron parts, and what they do is they'll 3D print the part, they'll put it inside of a sand cast, and then they fill that sand cast with iron. So even if you have high temperature metal applications, 3D printing could be applicable there. This is again the injection molding process, which I think is huge. It's going to change quite a bit in terms of high customized parts and products without the need to have to sell 100, 200,000 units to be able to justify the cost of your mold. Now you can just 3D print the mold and you can have short run, highly customized parts. So I think this is going to be a huge market for 3D printing. Parker Hannifin, this is just a nice case study up here. They currently are saving about $250,000 a year on prototypes because they brought this in-house. So they don't use the more costly, ineffective methodologies that they used to use. Now they actually 3D print and they're able to prototype things and save significant amount of money on an annual basis using these 3D printers. So that said, thank you. I know I went a little bit over on time. If you do have any questions, feel free to contact us, sales@wb-3d.com. I will also be following up with a thank you email to all the attendees for taking time out of your lunch on Friday. I think what we're going to end up doing is, I think our 2 o'clock time was the best time. So I think moving forward, 2 o'clock is going to be when our webinars are, but I appreciate you guys meeting with us at your lunchtime. Enjoy your Memorial Day weekend. And thanks again. If you have any questions, feel free to ask, and enjoy your day. Take care.